Today's objective is the area of parallelograms and the area of trapezoids. So, you know, to find the area of a rectangle, you could draw a rectangle, and I just drew one corner showing it's 90 degrees. You could say the bottom is the length and the side is the width, and you could say the area would be the length times the width. Or you could also name the sides, the bottom, the base, and going up the height, and say the area is the base times height. Those terms are often interchangeable, okay, especially in a triangle. And you also know that the area of a square is special because all sides are the same, so you could just multiply this side by this side and say it's side squared. Okay, that's a special area for a square. But you can also use the area formulas for a rectangle, length times width, or base times height. So, if you take a rectangle and push it over on from one side, you get a parallelogram. So once we just take this and push the top over, the base stayed the same, but the top part scooted over, and now the sides aren't straight anymore. The bottom and the top are still parallel, but the sides are parallel, but they're not perpendicular. So think about this. We could cut off, let's spell off right, we could cut off a triangle from one side and glue it to the other side and make a rectangle. So here's my parallelogram. I'm going to take the pink line, I'm going to cut here, and I'm going to move it over to this side. And now, all of a sudden, I have a rectangle. Okay? You see, can you picture that? Some people are much better at picturing than other people. Their brains just don't work that way, but hopefully you can picture that. So we can use the bottom measurement, which is the base, and the height measurement, and notice it's straight down from the upper left-hand corner. That's the height measurement, and it makes a 90-degree angle at the base. Okay? We can use those measurements to find the area of our parallelogram. So when we have a parallelogram, we can't use all the sides like we can in a rectangle. We have to use the sides that meet at a 90-degree angle. So we always have a height measurement in here, and we have the base. So the area for a parallelogram, we always use the formula base times height, not the side. Okay? This is very important. To find area, you must use measurements that meet at 90 degrees. Okay? You must have the 90-degree indicator for area. This is very important. All right, but you would still use the side measurements to find the perimeter of a parallelogram. The perimeter is still 2 times the length plus 2 times the width, because there's 2 lengths, there's 2 widths. And that would be for a rectangle or a parallelogram, or you could use it for a square or a rhombus. But for a square and a rhombus, since the sides are all congruent, you could also say perimeter is 4 times the side measurement. And these are supposed to be a review, so that's not why I'm not really working on that too much. More just a little bit on area. All right, let's say I gave you a parallelogram and I told you the area is 48 meters squared, the base is 16 meters. How would you find the height? Well, you could write down the formula for your parallelogram area, substitute in the numbers that you know. So if area is base times height, and the area is 48, and the base is 16, you could say 48 equals 16 times height. And now how do you isolate the variable? Divide both sides by 16. So the height is 3 meters. Okay, so we could write that in. Here's another problem. I'm telling you the base is 7 centimeters. The height is twice the base. Okay, so if this is 7 down here, this is 2 times 7. So what would that be? 14. So I'd like you to find the height, then find the area. Well, we just found the height. We could say the height equals 2 times the base. So the height is 2 times 7. So the height is 14. Okay, and you could just do it in your head too on this, right? And now finding the area is base times height. So now I know that it's 7 times 14. So that would be 7 times 10 is 70. 7 times 4 is 28. Add those together. 98 centimeters squared. And the reason it's centimeters squared is because really it's 7 centimeters, let me write that in, times 14 centimeters. 7 times 14 is the 98, and centimeters times centimeters is centimeters squared, because anytime you multiply something by itself, you can just say it's that thing squared, right? Like the side measurement, side squared. All right. Now let's talk about a trapezoid. A trapezoid has two pairs of parallel sides, erase that. A trapezoid has two parallel sides. A parallelogram has two pairs. Okay, a trapezoid just has two parallel sides, the top and the bottom, which is one pair. Okay, this is an isosceles trapezoid because these two sides are congruent, and remember the arrowheads mean the parallel. It's like you took an isosceles triangle and cut off the top. Like I could go like that, and you see it would be a triangle, and I just cut off the top. Okay, here's a boring trapezoid. Not really, it's just a regular trapezoid. It's non-isosceles. It doesn't have to have a 90-degree angle. I just drew this one having one just because of the way I drew it. All right. Remember how we changed the parallelogram to be a rectangle? We said it's pushed over, so we cut off a triangle and put it on the other side. Well, we can change a trapezoid to be a parallelogram by cutting it horizontally and gluing the top side down to the bottom side to make it longer. So let's look at this. So here's our trapezoid, and the two places that it could sit on evenly are called the base. Base 1 is at the top just because it's at the top, and base 2 is at the bottom, and this is the height. They don't call it the top and the bottom, okay? Anything that a shape can sit on is called the base. So base 1, base 2, height. Now what I'm going to do is I'm going to cut this just perfectly in half, and we're going to do this in class, but if you're not in my class, let's talk about it. We're going to cut this perfectly in half. I folded it and cut it in half, and then I'm going to flip that side over. Okay, so that's what I did. I just flipped this side down to here. Now my base goes all the way along here. My height is only half of what it was, because here's the half and here's the other half of the height. But notice how now it looks like a long, thin parallelogram, because these two are parallel, because we cut it in half. These two are parallel, and top and bottom. So let's look. So we can now use the parallelogram area formula. Area equals base times height. We just need to fix two things in that. The base is base 1 plus base 2. Okay, we can't just say base because it's this whole long length. And the height is half of the original trapezoid. So the area of a trapezoid, we would say area is, instead of just base times height, base 1 plus base 2 times half of height. Okay, see how this would, for a parallelogram, it would be area equals base times height, but the base is longer and the height's only half. However, we don't write it that way. We formally write it, area is 1/2 the quantity base 1 plus base 2 times the height. And because in algebra we always write the numbers first that we know, which would be the half, and then alphabetically. So we put the bases before the height. So let's do one of those problems. I know it looks really weird, but just think about it. We've taken our trapezoid, cut it in half, flipped it over, and so now our half is half the height. And our base is, base 1 plus base 2 length. It's not twice as long because they're not the same size. So here I'm telling you, base 1 is 3 inches, base 2 is 9 inches, and the height is 2 inches. Let's find the area. Write down the formula. Area is 1/2 times the quantity base 1 plus base 2 times height. So we do 1/2, 3 plus 9 times 2. I'm going to do order of operations in this one and add 3 plus 9 and get 12. Now you can take half of the 12 and get 6 times 2, which is 12. Or you can take half of the 2, which is 1. 1 times 12 is 12. It's just easiest to take half of your even number, okay? However, don't do order of operations. Don't do the distributive property because that technically wouldn't be correct. You wouldn't do multiplying before you do parentheses. And it's just a lot more work to do half of 3 and half of 9 and add them back together, okay? Even though it is 6. All right, here I have a trapezoid with an area of 54 meters squared. The height is 6. Base 1 is 8. Find base 2. Okay, so let's write down the formula. Area equals 1/2 the quantity base 1 plus base 2 times the height. And I told you the area is 54. So 54 equals 1/2 8 plus, I'll put in an x, times 6. Okay. Let's do, in this case, let's rearrange, with multiplication, the order doesn't matter because it's commutative. So I want to do half of 6 since I can't add these together and I don't want to do the distributive property with a fraction. Half of 6 is 3. So now my problem is 54 equals 3 times 8 plus x. Now I can do the distributive property. 54 equals 3 times 8, 24, plus 3 times x, 3x. Now, how will I isolate my variable? Do the inverse operation. So subtract 24 from both sides of the equation. 54 minus 24, let's go up here, is 30. So 30 equals 3x. So what's x equal? X equals 10. Am I finished? Yes, in this case I'm finished because I only need to find one side. So that means this base equals 10 meters. Remember, when you're doing measurement, you always have to have what the unit is. And if it's not given, you just write units. And that's it.